Question 1. Simplify 3q to the 4 all squared over q to the 3. Right, we'll put the front number to the outside power. That 3 that's in the term there, we'll put that to the outside power because that 3 is in the bracket and it is getting squared as well. So we'll make 9 for that number and put that there. Then we'll follow the rule. When a power is put to another power, we multiply the indices. So we'll get q to the 4 times 2 or 8 there. So we'll have 9q to the 8 on top and we'll have q cubed or q to the 3 on the bottom. Then we can keep simplifying here to divide terms with indices, which is what's happening with the q's. The bottom is dividing into the top there. We subtract the indices. So we'll subtract the 8 from the 3 or the 3 from the 8 and we'll get 9q to the 5 in the end. So when we do that, that q to the 3 kind of disappears. So our final answer there, 9q to the power of 5. Question 2. Simplify 3 times a cubed all squared. When a power is put to another power, we multiply the indices. So a cubed squared makes a to the 6, and that 3 is just left out the front. Notice the 3 isn't squared because it wasn't in the brackets. That 3 is just multiplying out the front there. So we end up with 3a to the power of 6. Question 3. C squared cubed over c to the power of 4. Simplify. When a power is put to another power, we multiply the indices. So we will multiply that 2 times the 3 there for the top. So we'll have c to the power of 6 following that rule, and we have a c to the 4 on the bottom. Now that c to the 4 is dividing into the c to the 6. The bottom of a fraction divides into the top. So to divide terms with indices, we subtract the indices. So we're going to do 6 minus 4 there. And we'll end up with c squared for our final answer. Question 4. Write using positive indices 1 over y to the power of minus 2. If any term has a negative power, the fraction version can be turned upside down to create a positive power. So we already have a bit of a fraction version where we've got the y to the minus 2 here. So what happens is, if we flip that around, it's almost like the minus from the indices is effectively used up by flipping the fraction around. So we just end up with y squared once we've flipped that fraction. So that's how to kind of turn a negative power into a positive power, or express it differently. We turn the fraction that's surrounding it upside down. Question 5. Simplify a cubed b squared times a to the power of minus 2, b to the power of minus 4. Fair bit happening here. So to multiply terms with indices, we add the indices. So with the a's there, we've got a to the 3 and a to the minus 2. If we add those indices, we'll have 3 plus minus 2 makes 1. So our a is just to the power of 1. When we look at the b's, we'll have b squared and b to the minus 4. If we add those two together, we'll have b to the minus 2. Now, simplifying usually asks for positive indices or positive powers. So what we're going to do is follow this rule. If any term has a negative power, the fraction version can be turned upside down to create a positive power. So in the b to the minus 2 section there, it's over 1. We've put it over 1 to make it into fraction form. So if we turn that upside down, that uses up effectively the minus from the minus 2. So that's the way to get a positive power for the b. Instead of b to the minus 2, we have b squared. It ends up being on the bottom, but that's okay. Then we'll multiply across the top and across the bottom to simplify in our final way here. A times 1 is a, and 1 times b squared is just b squared. So in that way, what we've done is we've followed the multiplying terms with indices and added the indices along the way, and we've also tidied it up by turning a negative indice into a positive for our final expression. Question 6. Simplify m squared n squared p cubed all over mnp. Alrighty, so here we've got that. Now we consider those m, n, p on the bottom to all have an invisible 1 as their power. That'll help our thinking a lot here. And they're all dividing into the top there. So when you divide terms with indices, you subtract the indices. So we're just going to go through one letter at a time here. M squared divided by m to the 1, we'll subtract the indices. 2 minus 1 makes 1. Don't have to write the 1 in there, but that's an m to the 1 that we've written there. With n's, we've got n squared divided by n to the 1, so we'll subtract the indices. 2 minus 1 once again gives us n, or n to the 1. And with the p's, we have p cubed, or p to the power of 3 on top, divided by p to the 1. If we subtract those indices there, 3 minus 1 in this case is 2, so we get p squared there. So final answer we end up with, after subtracting the indices, mnp squared. Question 7. Write using scientific notation 20,000. The decimal point in scientific notation goes after the first non-zero digit if you're reading from left to right. So we want the decimal point to move. Effectively now, it's after the final 0, the decimal point, but it's invisible. We don't have to write it in for a normal number. That's where it's situated. We want to move it so that it's between the 2 and the first 0. So we need that creates a number between 1 and 10 multiplied by 10 to the power of something. Now that power is indicated by how many jumps you have to make with the decimal point. So let's see how we go. So that decimal point I'm saying is invisible at the end there at the moment. We want to move it how many times? We want to move it 4 jumps to the left there. So it's almost like we want to multiply it by 1 with 4 zeros next to it. So anyway, the decimal point's jumped 4 places. So we need to sort of compensate for moving that decimal point by multiplying it by 10 to the power of 4. So see how the number of jumps matches the indice that's going to be to the 10 is to the power of once we write it in scientific notation in the end. So that's the way it works. So 20,000 equals 2.0 times 10 to the 4. Question 8. Expressed in decimal form, 6.2 times 10 to the power of 3. Alrighty, so if you times something by 10 to the power of 3, it's like you're timesing it by 1,000. So we move the decimal point 1 jump for every 0 in that situation. That power of 3 tells us how many jumps to make with the decimal point to turn it into a normal number, or a decimal. So that 3 indicates that we'll move the decimal point 3 jumps to the right, because multiplying something by 1,000 makes things bigger, so it is to the right that the decimal point is expected to move here. So we'll move it 3 places to the right. Now when there's jumps of the decimal point and it doesn't seem to have any digits above it, we're going to fill them in with zeros just to make sense of it all, just to make the 6 and the 2 stay in the right place value there. So when the decimal point jumps 3 across, instead of being between the 6 and the 2, it's now at the end there, and we've filled the spaces in with zeros. We turn 6.2 times 10 to the 3 into 6,200. The decimal point doesn't even appear in our answer, but it's like effectively we know it's off to the right hand side there. Question 9. Write, using correct scientific notation, 42 times 10 to the 4. Now it looks like 42 times 10 to the 4, some might think it's already in scientific notation, but no, we need that front number, where the 42 is, to be a number between 1 and 10 to be proper scientific notation. So that's what we're going to have to do here. We're going to have to adjust it just a little bit. So at the moment, 42 has a decimal point that's invisible to the right of it, as I've indicated there with the 42 and the dot. So we need to move it 1 jump to the left to make it into a number between 1 and 10. Alright, so we need to jump it 1 to the left. Now we're going to have to compensate the 10 to the 4 there by the fact that we've moved the decimal point 1 over. So this is to get a number between 1 and 10. We've got now 4.2 instead of 42, so that's between 1 and 10. And this is equivalent to dividing by 10. When you divide by 10, you move the decimal point 1 jump to the left. So what we've done is divided by 10. So we need to make up for this by kind of multiplying by 10 where the 10 to the power section is. So we need to add 1 to the power that we had before to compensate for the fact that we randomly divided by 10 on the left-hand side there. So a bit complicated, but anyway, we turn the 10 to the 4 into a 10 to the 5 to make up for the fact that we moved the decimal point 1 to the left, but at least we have turned things into a proper scientific notation by having a number between 1 and 10 out the front, times by 10 to the power of something or other. So just a little adjustment, but it was fairly complicated in the end. Question 10. Simplify, writing our answer with positive indices, 3c to the power of 4 all squared times 4c squared d all to the minus 3. So a fair bit happening here, so let's have a look at the front number of the first bracket there. We've got a 3 in the bracket and it's being squared. The bracket's being squared, so we'll need to do 3 squared. And on the right hand side we've also got, well, that makes 9 of course, 3 squared. And in the second bracket we've got a 4 that's in the bracket and the bracket's being put to the minus 3. So we're going to have 4 to the minus 3. Now let me explain this bit just briefly. The minus means 1 over 4 to the 3. So what we've got is 1 on the top and 4 to the power of 3, which is 4 times 4 times 4, making 64. So in the end, 4 to the minus 3 for the number that's resulting from that second bracket is 1 over 64. So a fair bit there. So that's the numbers part. Now let's do the letters. When a power is put to another power, we multiply the indices, remember. So we've got c to the 4 squared there. So we'll multiply those indices and make c to the 8. And on the right hand side we have c squared times minus 3, which makes c to the minus 6 when we multiply. So 2 times minus 3 is minus 6. And for the d, it's like it's got an indice invisible of 1. So 1 times minus 3 is just minus 3. Okay, let's keep working here. So we need to express our answer with positive indices. So we're going to have to do a bit of switching for the c and the d term here. So we can have our normal 9c to the 8, but just to help our brain, we're going to put it over 1. We've got times 1 on 64. Now c to the minus 6, what we do is, if any term has a negative power and we want to express it as a positive power, the fraction version can be turned upside down to create a positive. It kind of uses up the minus. So if we considered the c to the minus 6 to be over 1, which we're allowed to think of it like that, and we switch that around, we get a c to the power of positive 6 on the bottom. And we're going to do that with the d section as well. So consider the top bit, d to the minus 3 to be over 1. And if we have that fraction version and turn it upside down, we use up the minus and we create positive indices there. So that's quite a lot, but I've written it out as carefully as I can there to show you every part of it and what's happening there. So to divide terms with indices, we subtract the indices. So you can see we have a c to the power of 8 up the top and a c to the power of 6 on the bottom. I know they're on different fractions, but when we're multiplying, we're allowed to combine things that are on the top of one fraction and the bottom of another fraction. Only when they're multiplying, of course. So we can subtract those indices, c to the 8 and c to the 6, so we get 9c squared on the top, times 1 times 1 times 1 across the top there, so that's just going to be 9c squared. And then on the bottom we have 64 lots of, now the c to the 6 has already been merged into the c to the 8 there to make our c squared. So we're left with 64d cubed on the bottom. And apologies there for the 16 steps or whatever we did there, but it was probably good for our brain.